Hello everyone, welcome to the video on design of STATCOM. This is the part one. In this circuit, in this video, we are going to design a DSTATCOM power circuit first. In the next video, we will design its controller. So for a power circuit, this is my requirement. I want a three-phase supply with 50 Hertz with a resistance of 0.9 ohm. I want to keep a very small resistance at the source, three-phase source. Then load of 10 kilowatt, 12 kVAR load means almost 0.64 power factor load I want here. For which we need to design a DSTATCOM such that it will compensate the reactive power of the load. So let us begin with the designing the power circuit first. So first I will take three-phase source. In this three-phase source, the RMS voltage we want to set it to 400 volt. Frequency is the 50 hertz. Then I'm setting the resistance as zero point 0.9 ohm. Inductance value I'm keeping to the 0, and the base RMS voltage is 400 volt again. So, and configuration is star ground. Okay, so it's apply. Okay, so you can observe here, this is my three-phase source. Okay, so let us zoom somewhat so that it will be visible to you. Okay, after this, we need a three-phase VI measurement block. So take the three-phase VI measurement block. Okay, in this three-phase VI measurement block, we want to convert this as a bus. So we want to measure here the phase to ground voltage. Okay, I will use as a label. So this is the source side voltage. So I will give the name VABCS, or for simply, as we are going to do all calculation in three phase, I will give you only VS name. Similarly, I want the current measurement in terms of label. So let this is the source current IS. Okay. Now you can observe this is the VI measurement block. Now right click on this block. I want to convert it as a bus. So you can go in a format, background color, make this color as a black. So you can reduce this thickness, so it will become a bus. So connect A here, B here, and C. So this is the ABC connection. Now we want a load. So take a three-phase load, three-phase RLC load, series load. So I will bring this load here, rotate this load, Control R, then it will rotate, align this with the source. Here I want this 400 volt RMS, 50 hertz supply, 10 kilowatt the active power, and reactive power I want 12 kilowatt, that is 12 e raised to 3, and there is no capacitive power. So capacitive power I'm keeping C is equal to 0. So load is converted into RL. Okay, now drag this same block here, and I want to connect this measurement block here. But in this measurement block, these names must be VL, IL. Okay. Now I will connect this to the load. So it will measure the load side parameters. Now you connect this both together with a line. So it is a source connected to a load, simply system source connected to load. So now let us observe the first waveform. So what I will do in this circuit only, I will add the measurement block. So measurements I will add here, that is the scope. So take the block of from. Okay, let's go below. Here I will add the measurement. Here I want to measure the source voltage Vs. Then I want to measure the source current. is. Then I will copy these two blocks two times once again. Okay. I will rename this with VL. I will rename this with IL. Okay. Now you take a scope, well click to the scope. We'll change the scope properties first. Let the scope properties is to open. Okay. So in this scope properties, I will change this to number of axes as a 4. I will change its layout. Okay, we'll make this layout 2 by 2. Okay, now increase the scope. Arrange it properly so that it look nice. Okay, so now first we will then I want to measure the power. So let's call a power measurement block. In a power measurement block, you take the power three-phase power measurement block. Okay, so in this three-phase power measurement block, I will add this three-phase power measurement block here. First, I will connect the source, then source current. Here I will get a source active power and reactive power. I will add it to display. Or first we'll measure the power factor. So how to determine the power factor? For power factor determination, we need Q by P and take the tan inverse of that. So we will get the power factor angle. From that power factor angle, you can determine the power factor. Or second method is P divided by S. How to calculate the S? S is equal to square root of P square plus Q square. So what I will do, I will take a square term. Okay, so I will connect this square term here. Then same, I will copy, I will paste here, square term here. Then you add these two terms. So P square plus Q square. After getting the P square plus Q square, take the square root of that. So SQRT. So take the square root of this. So it is the S value. Now take the term of divide. Okay, so P divided by S. So take the P from here divided by S and then click on display. So it will display the power factor of the source. Now similarly, you copy all this and paste one more time, arrange below this. So you change this block as VL and change this block as IL. So here you will get the power factor of source, here you will get the power factor of load. So let us simulate this simple circuit. I will save this circuit first. uh, I will change the simulation timing to the 0.25 seconds. Okay, 0.25. uh, okay, and run this simulation. Okay, it's compiling, it's running. Okay, maybe there one error, IA, IB, IC. Okay, let's check in which block this error is occurring. Okay, so diagram needs power GUI block. I forgot to uh, take a power GUI block. So if you read the error, it will give you the status. And in this power GUI block, you choose the discrete and keep this timing up for, okay, what we'll do, we'll keep this timing. Let me check how much time I have kept. 5 e raised to minus 6. Okay, so 5 microsecond sample time you keep. Okay, so 5 microsecond. Now you can run this simulation. Okay, or let me drag this power GUI block here. Now you check this. This is my circuit. Okay, so let's rearrange the circuit so I can see everything in one window. Okay, now let's run this circuit. Okay, so block parameters are open. Let me first apply it and close. Again, run it. It's initializing, it's running. Okay, here you can observe this is 0.6464 is the power factor. Okay, one small thing I want to change here, that in power measurement block I need only fundamental power. So I double click to this, make the frequency 50 hertz and harmonic order 1. Okay, so I don't want the other harmonic order 50, and harmonic order is fundamental. That is 1. Now run again this circuit. So let's observe over here. You can check the power factor is 0.6402. Let's check the waveform. Okay, so take the horizontal zoom. Check this much. You can observe here the R phase current is lagging to the voltage. So this is the source voltage, source current, load voltage, load current. Okay, so load voltage and load currents are source voltage and source current are same here. So if you want to add the name, you can add this name into this block as source voltage, source current, load voltage, load current. Okay, if you run it once again, it will display that name on the top of each waveform, so you will not get confused then. So see, source voltage, source current, load voltage, load current. These waveforms are visible here. If you want to change the display, you can go into view. Okay, then go to the configuration parameter. In this configuration parameter, you can change. Okay, so the colors are not, I think, in this. Okay, you right click on the graph. Go in the style. In this style, it will open. You can set this figure color to white, axis color to white. Okay, then this color you can keep black, line color. Every line you can change to the 2 per unit. Okay, this will change your colors of your graph. Okay, now we are done with the power circuit, but we want to attach the voltage source converter to this. So to attach the voltage source converter, again you need three-phase VI measurement block. So I will copy this three-phase VI measurement block which was earlier there here. Let me open this block first. I have changed the background color to black. So again, I will change this background color to white. So you can observe here, because these names are very important while connecting. You rotate this block such that capital ABC on a downside. Okay, so let me check once again. Capital ABC names are on downside. So ABC. Then you take the three-phase bridge. Okay. So universal bridge. In this universal bridge, you change this 3-arm OK. Instead of thyristor, make it MOSFET IGBT based. So we'll make the IGBT based. Okay, then you rotate this such that ABC on forward side, but see here, the names are C is here, B, A. So we want to change the nomenclature from left to right. So click on flip block and change left to right. So now you can observe here the ABC are here. So below ABC, we will have to connect this ABC. But before this, we want to put one inductor in the circuit. So three-phase inductor we need. So take the three-phase series RLC branch. Okay, in this series RLC branch, make this one inductive and set the inductance value to the 2 millihenry. Okay, then rotate it. Again, if you want to change this name, okay, right click, then go in the format in the flip block. Okay, flip block name. Sorry, go in the format. Okay, in this case, I think we cannot change the left to right or left to right, because inductor uh, it is not a polarity. For a inductor, there is not a requirement of polarity, so you can connect either way. Okay, so we have connected the inductor in the circuit. This is a 2 millihenry inductor. Now we have to connect this phase A to phase A, phase B to phase B, and phase C to phase C. Here I want to change this three-phase VI measurement block as these are the compensating current, so VC and compensating voltage and compensating current. So I will name this VC and IC. Okay, coming to the secondary side of or other side of the inverter, we need here a capacitor. So series RLC branch we need. In this series RLC branch, double click on this. We want only capacitance C, and the value of the capacitance is 4700 microfarad, that is 4700 into E, and we want to set the initial voltage to the 800 volt. Okay, so we'll change this to the 800 volt. We'll connect this capacitor here. Now our circuits are ready, but we want to use the gate here. So take the block of from, connect this is to gate block, and connect here. So we want to apply the gate signal over here. So how to apply this gate signal, we will see in the next video in the controller design. Hope you understand this power circuit design. Okay, so in this power circuit, we design power circuit first with the load and source, simulate that first, check the power factor, whether it is giving the required power factor. Then you connect the voltage source inverter with the help of inductor. Please take the care of polarity of VI measurement block. Okay, with this, we are at the end of this video. Watch next video for the simulation.